Hi, hello. I'm recording a kind of whiteboard interview type of thing, but I decided that not a lot of the whiteboard interview questions are kind of these theoretical, you kind of learned problems that a lot of people end up tackling, and books are written on these problems, and you can go find and solve these problems, and they don't actually give you any sort of taste of what a person can really solve in the wild in an actual project. So I've decided that today I'm going to record some work I'm doing in a custom C++ engine side project that I have going on, and kind of talk through out loud some of my software engineering thoughts about this specific change that I'm making, that I've been thinking about making for a while now. And I'm glad to have the opportunity to explain my thought. So the first thing I'm going to do is kind of explain what this project that we're looking at is. It's a custom C++ engine. Right now, all it does, it's based off of ECS, and specifically the ECS outlined in the Blizzard talk from a few years ago, where they talked about their gameplay systems and netcode. They outlined an ECS system with a way to query their entity set using component types and to aggregate those things. So that's kind of what we have here. And in that system, all we have right now is this simple asteroid clone looking thing. And I've worked with the system before. I've implemented it before. This is the second time I've implemented it. And we're kind of early on enough in this project that I've decided that we're going to be a bit more skeptical about our software engineering, and take a look at this sort of ECS system and the fine-grained details of our implementation, and make sure that it is nice to use, that there aren't going to be problems with it in the future, and there isn't anything annoying about using it, because right now the project is small enough. Obviously, this asteroid scheme is only a few lines of code, some acceleration, some velocity, etc. I really want to make sure that the format that we've decided to go with how to query our engine for game state is going to be scalable and effective for a while to come. And so I was looking at, this is what it looks like right now. I'll take you through the simplest thing. This is the input update, and we're looping through a set here, and a set is a combination of two components. The two components in question are the player component, which stores the position and rotation information of the ship, and the input state component, which theoretically records the input values of like the 4 input arrows. However, right now, and that'll be useful when we actually do get to the point where we have where our input querying is being done somewhere else, but right now we're kind of just querying it right in the update loop, because we have this temporary Windows situation. That renderer that I was just showing you is a simple Win32 line renderer. I'm just literally calling 3 line calls to draw that spaceship. It's definitely not a scalable solution. It's not the end solution. And so I'm preparing myself for the inevitable solution where I'll want to be doing the input querying next to my window management, rather than just doing it willy-nilly wherever I want to. So that's what this component is here for, and that's why we're looping through a set of components. And so when I say loop through a set of components, what it means is give me every entity in this component store. That's what this store stands for. So, and the component store right now, there's just one global store. So loop through every entity in the component store that has both of these components. And so for each entity that has all these components, which obviously there's only one for now, as you can see this for loop through this entity create layer, we may be changing that in the future. For each of those, do some logic. And specifically, we take the input information, and we're doing some very simple physics simulation on that to do acceleration, linear velocity, angular velocity, etc. Oh yeah, we don't have vectors, so yeah, because like I said, a janky rendering system. So we're just doing float arrays, and we're not going to have to mess with that too much today, thankfully. That's not our problem. But yeah, this is going to have to be fixed eventually. Yeah, because in the render, we have to do, I have to create a rotation matrix out of this stuff, and this is what that looks like. Not fun. Not fun at all. Anyways, so yeah, so this is the question that I want to answer today. Is right now we are using this loop through store component, and we're passing a C++ lambda. And so don't get me wrong, I like lambdas. I like the feature. It has some problems. In this specific instance, those problems are not very visible because, specifically the problem that I'm looking to solve with this change I'm going to be making is the closure problem, where the lambda wants access to data in its creation scope to be used in its function scope. And to do this, the lambda syntax has this square bracket space where you can outline what you want to capture and how you want to capture it through some archaic syntax that you have to look up every time because no one's going to remember it. Specifically, this ampersand only syntax that you see here means take a copy a reference of each one of the local variable states and put them into, and allow me access to them in my function scope, which is why you can see we can access the input booleans that we have established up here. And so the reason why this is problematic is because, first off, I just don't like the syntax. This capturing syntax can be confusing. Like I said, you have to look it up every time. It doesn't scale well. There are differences between when you want to capture things by reference versus when you want to capture them by copy, and you have to remember the differences. And when you don't want to capture everything by one way, you kind of have to start specifying everything. And honestly, I don't even know the full extent of this capture. Is it capturing all my global information? Do I have access to that now? Probably. Actually, yes, I do, because I'm modifying it here, so I must. So there's this small character has a lot of impact on what exactly this lambda is, and it leads to some confusion on my part, and I actually don't know how big this lambda is. If you ask me how much allocation space this lambda specifically takes up, I do not know. I could not tell you. And so, while I'm sure it's still being allocated on the stack because it must know how much space is being used, the compiler probably knows. I can't reason about it, so I don't particularly like this solution. And in the future, it's only going to get more confusing. There's only going to be more global variables, more local variables, and that's going to cause more problems with the size of this lambda and the inevitable hard copy we're making of it in order to pass it to this loop through store. Or maybe here's the second problem, is that in order to pass lambdas around, you kind of have to use this weird, because obviously I don't want to make an std function out of this for a lot of reasons, specifically because std function is going to make a dynamic allocation in order to store all your information for the lambda. No, I'm going to use this this template format in order to do that, and we're going to use a forwarding reference, and just things get messy. Every time I want to pass a lambda like this, I end up having to do this kind of forward reference nonsense. And so I've decided I don't like this. I don't like this. I don't think it's scalable. I don't think it's going to be a good solution going forward. I think we can do better. So what does better look like? Theoretically, the thing I'm going to try next is going to be kind of a reversal of how it works right now. Right now, the top level function, the update function, calls the store's loop function, and then you kind of use it like an algorithm, and you pass a function to it. I'm going to borrow some more concepts from the standard library, and instead of using this algorithm approach like I am now, I'm going to use an iterator approach. Or as I'm going to call it an accessor, because I don't want to use the word iterator, because the word iterator kind of, and one of the things you can do with iterators is kind of manipulate the storage as a whole, the collection as a whole, and do like sorting algorithms and things like that on the entire collection. That is not something I want people to be doing over the store all over, but although theoretically possible, it is bad form and would be very strange to do those kind of operations on this component store. So instead of calling it an iterator and getting all of that nonsense tangled up, all that terminology nonsense wrapped into it, I'm going to invent a separate concept, which we do all the time, and of course it's I'm just adding to the problem really, but I'm going to call it an accessor. There's one more way I'd like to talk about on how to kind of approach this that I thought about. So if I recall right, I've seen people like in Handmade Hero where they instead of letting they take the same sort of approach where they have the algorithmic solution where they throw the closure and the function pointer, and they call the closure a user pointer instead of a closure, and they still use the same format where the update function is calling an algorithm on the component store, or I don't know if these are exactly the nouns or the types of things that they're doing this with, but the point being is that they're still allocating based on how much information the function needs. My solution inverts it, and it's allocating based on how much the looping and the iteration needs. The reason why I think this is better is because the amount that the iteration needs is a fixed amount. There's only one. Our iteration algorithm. Wow, what a sentence that was. Our iteration strategy in order to get through the component store only works one way, and we know how that works, and so we know exactly how much we're going to allocate. If we're talking about the other way around, we're talking about the types of things we want to do while iterating over all these components. There's literally infinite things that we could want to do to the component store. Excuse me. And so there we have the scaling issue where potentially we could end up allocating something up to like 100, 200 kilobytes in order to pass the user data along with the function pointer. And so if we just invert that logic, we will end up, on average, probably saving time. It depends how much these closures, how big these closures end up being on average. I don't rightfully know. But at least it'll be a fixed amount rather than a variable amount depending on what routine or what function pointer you're passing. Okay, so that's the plan, is that instead of passing this lambda, I'm going to, from this loop through store function, return an accessor and then change this lambda into a regular while loop that uses the accessor to loop over the store. I'm not going to change any function names. Well, maybe I will. I don't know. We'll see. I'm going to try to make this, I'm only going to do it to this one function for time purposes and try to keep this as short as possible. But the first thing I'm actually going to do is I'm going to set up my environment so that I can tell if the changes I'm making are positive or not. So right now, as you may have noticed before, we're being frame capped. So you see we're only running at 90 frames a second. That's on purpose. I have a frame cap loop. Our engine can definitely run a little faster than that. So I'm going to I'm going to change the system in such a way that this loop through store functionality and this update function actually takes a significant amount of time. And it's a fairly easy way to do that. One, I'm actually going to turn off the render as a whole. So turn off the awake, turn off the start, and turn off the update functions, and then get rid of the frame limiter. The frame limiter exists because the Win32 drawing API is a little trash. I say that aggressively. The Win32 drawing API can't handle you drawing more than about 60 times a second. Kind of pushing it with Mindy just to see what happens. It just doesn't like being drawn that much. It doesn't like having to update the window that often. I don't know if it's updating the window, because I imagine that OpenGL and Vulkan and DirectX are all using that same window update function in order to, or not the window update, but invalidating the input. That's what they call it, or invalidating the Windows space. So I imagine that's what they're using, or maybe they're using some lower level integration that they've kind of hacked in to the Windows operating system. But they're likely using that same Win32 call. It's specifically the painting procedures that I imagine don't like being called that often. So, which is, again, something that's not going to be a problem once we remove that part of the render out from the game. Oh yeah, and the next thing I want to do, instead of polling for input, I'm going to supply some false input. Let's just say holding left and up. And then instead of 1 player, we're going to make 1,000. And that should be something. It should be slow, probably. Excuse me. Oh boy. MSVC build times. Alright, so I'm kind of just taking a look at this. Ooh, wow, we have a large variance here. But we're talking somewhere on like the magnitude of like 30 to 100, depending. I assume that's depending on how much processor time we end up getting per frame. I don't rightfully know. And because I'm not doing any averaging, like seeing this kind of spikes, it's pretty obvious. Let's see, would it be better if and the profiler? Maybe? This isn't going to give me that same information. I kind of like the FPS estimation, not because it's extremely scientific, but because it kind of gives me a really good idea if I've done something extremely bad. Oh, fun. Okay, here's a fun thing I learned today. After you stop your program, Microsoft Visual Studio keep this up, and if you don't close it, the next time you try to run it, it just will stall in the next printf zone. That's fun. We'll try this again. So this isn't going to give me, the profiler is going to give me data in a different way. Is the profiler running? Okay, thank you. The profiler is going to give a different set of information. The FPS is a really nice just kind of litmus test to see if any change I've made is pushing the awful. If we start seeing 5s, 10s in this set of data rather than the range that we're seeing, we'll know that we've done something extremely wrong. But what I want to see out of the profiler, yeah, so this is kind of what I want to see. The slowest thing right now is our unordered map lookups, which I may do something about one day, but it's still an extremely fast operation. This is theoretically a fast operation, so the fact that this is the slowest part of our game is good. There is something to be said for having to do this get component lookup. Sorry. So this is in the lambda. You can see that we're having to do the get component twice here, even though we're looping through. That's some more software designy things that I may think about in the future and may get rid of, but like that's a problem we have right now. Is if we're looping through a set of components, we still have to retrieve the components using get components because we're only given the entity that has that set of components. Because when we're looping over a set of components, we're not actually looping over the component arrays, or looping over the entity component bit fields that we use to compress the information of whether or not an entity has components or not. We use a vector of bit fields for that. All right, so finally, I think I'm going to start work on the problem that I outlined at the beginning, and we're just going to get right to that. So I think the first thing that I want to do, kind of want to take this that we're seeing right here, and I kind of want to mock what the API on this component store side would look like. So we kind of want something like that. So get that, and then this is the set accessor. And then we would do something like while. We could theoretically put that in here. This is going to be a very strange while loop. Let's go ahead and put that in here. And then we can have multiple set accessors in a single function. So this is genius. All right. And then something simple like set accessor finished, and then set accessor next. Something like that. And then we can say auto entity is equal to set accessor get. All right. And so this kind of gives you an idea of what we're looking. Oh wow, excuse me. There we go. This kind of gives you the idea of what we're looking to do. We have this set accessor object that knows when it's done looping. It knows how to loop, and it knows how to get the information from that iteration of that loop. And then we can use that information to do everything we were doing before. And all this information, that all this scope-based information that used to have to be captured by the lambda, it's now just in the same scope. So there's no capturing going on. We don't have to worry about that scale problem that I was mentioning earlier, where the actual functions and routines that we want to do on these objects have an unknown amount of information that it wants to pull in from the outside world. We don't have to worry about that anymore because that's all just in function scope now. It automatically has access to that information. We don't have to make another copy in order to give the lambda function access to that information. We'll still need to create this set accessor object, which is going to have information in it in order to be able to continuously operate this loop. However, we'll know exactly how much information that is, and we won't have to worry about any scaling issues with that. All right. So now that was the easy part. We're going to get into the hard part. Let's not modify this function. Because I do eventually want to, ooh, wait, am I spelling that correctly? Hold on. Hold the phone, accessor. It's not a real world, which is a word, so this doesn't help. Accessor? No. How do you spell access? Is that right? Access Florida. Microsoft Access. Alright, I'm going to assume that's the correct way to spell it, even though I'm not seeing a dictionary. No, I actually don't trust the Florida State Department to spell things correctly. Access. Alright, thank you, Google. I trust Google, though. So a thing that accesses is an accessor. Is it an accessor or an accessor? Oh, that's not spelled correctly. Wait, is it? I've already forgot. Accessor. An accessor, someone or something that accesses. Hey, there we go. Okay, this is an actual word. That's good. All right. So now that we know that's an actual word, I feel confident using it here. And so now we just have to get the set accessor. Alright, which means going into component store.h. Alright, so this is that function that we were just looking at, the loop through store function. We're going to make another one, void, set accessor. I actually don't know if a set accessor and no, it is likely. It is likely that a single accessor and a set accessor are going to look different, because as you can see, this is what a loop through store with a single component type in mind looks like. Very simple, handled at the slot map, or the slot map is the name of our memory manager. So at the memory management level, this has to do something slightly more complicated. Oh, which means that it's going to be a slightly more complicated accessor to write. But I think I should be able to just take apart some of this logic that we have here and use it. I'll go through this logic in a second. Let me write this function definition. It set accessor, and then we want component set. That's it. Oh, and this search mask. Those are two things I want. And then we're going to be lazy for now because this is kind of a whiteboard type situation. I'm just going to write the struct accessor right here, and we're going to get some information. All right, so let's go through this algorithm real quick. So the basic algorithm is we create a search mask, which is simply a search mask. All it is it's a character array or a U8 array that is the same size as the component set size. The search mask is, that might be some mem garbage there. Hold up. That might be a bug. Because it's hard to see now. Yeah, so this mask thing that I sent over is a U82, but I'm mem setting a full mask size. Oh, that's not good. Each one of these components has a U8 in it, right? I thought problematic. Okay, so this search mask is actually a bug. We're going to ignore it in the loop through store, but we'll fix it in the get set accessor. So the problem that we're seeing so the problem is I wrote this search mask, I wrote it in two ways. In the second way, I had assumed that the max size I needed was the size of the component types, or the types of components I need. That doesn't make any sense though if you think about it, because like a U8 is already a byte. Like really, you would only need, because this is a bit mask, so really you would only need one because there's two. And still, even if that were true, these types, their UIDs are unknown, so we have to allocate the full component bit mask, which is given here, the size of which is given here. So why am I should never be dynamically allocating it. We're actually fixing this right now. This is bad. Oh, I'm dynamically allocating it because I don't know, right, because it's C++ and I don't know the size of compile time. There's some garbage Microsoft function. I keep using that word aggressively. I should stop calling things trash and garbage. Apologies. There is a function in the Windows API that allows you to allocate things on the stack. which would kind of be perfect here. Or I could have like a full arena allocator setup or a frame allocator setup, but like I don't have that. This is rough. Okay, I think what we're going to do right now is we're going to get rid of the bug and not worry about premature optimization on this, and note that this is something we're going to want to fix in the future. So the search mask is just going to be a new U8 pointer. This gets rid of the bug. These kind of naked allocations are a little terrible, and I don't want to be doing them. Get that double underscore, so we're not using it anymore. I don't love this, obviously. This is a patch because this bug is horrendous, and I don't want to. And it's likely that, it's possible that in whatever I'm doing in the future, even in the short whiteboard, that I could be affected by the outcomes from setting that random memory space that I shouldn't be getting access to. But now we should be good. That's also memory release. Excuse me again. Delete. Search. Alright. Crisis avoided. Now, back to what we were doing. Oh, goodness. Am I going to have to do the same thing here? Yeah. Yeah, I am. Is there a way you can get around this? No, I could. Is there a maximum component size? Because I could do something like that, where I just up front allocate the full size. No, there isn't anything like that. I could do some janky stuff. Let's not do janky stuff. I was thinking the set accessor could be a header to a set of memory that's used like this. However, I'd still have to be in the situation where I have to dynamically allocate it rather than statically allocating it. So I still have the same issues. The nice thing about being past this array was that the owning function could decide how to allocate it, which means it could decide, hey, this and it's still the same benefit that we get here. This iteration, this looping may be a multi-frame operation, which could be bad anyways due to the nature of the beast, due to multi-frame operations are always going to be a little stranger than single-frame operations, worrying about object and component deletion and instantiation. Not something I really want to do. It kind of has all the same problems that like a multi-threading setup would do, except instead of getting the benefits of multi-threading, you're just doing things over this set of frames. So that's a problem with that example. But point being, it could decide to use a frame allocator, an arena allocator. It could decide to allocate in some memory that it has for this specific purpose. I think it's good to pass in the information here. However, how I'm passing in the information here is incorrect. So instead of dealing with that bug, for now, we are going to do the same thing here, I think. I don't think I need to memset that, but better safe than sorry. And I actually think we're going to have to pass this around in the set accessor too. Search mask. And then we're probably going to want the component set to do the iteration. Let's see, let's just try. So what are the two functions we needed? We needed get and next, right? Those were this is the renderer. Close the renderer. Get finished next. Okay. Ooh, finished. Void next. Entity handle get. All right, so we're fulfilling our contract now at the very least, but we're really not doing that good of a job. Oh, so here's the code. This code sets up the mask. So that's good. I could put this stuff in a constructor for the set accessor, but the weird rules with C and C++ when you start defining constructors on classes, it deleting the default copy, it deleting the default move constructors. I don't want to deal with that. I want to keep as much code out of the class as possible, to be honest. So I'm going to purposely ignore that now. Oh geez. Wow, look at my naming schemes. Alright. And then we're also just going to copy this. So here you can see me taking that approach again. Oh geez, this may be multi-layered. Because this, it's really calling out to this here, this loop handles function on the slot map once again. Okay, so a couple ways come to mind on how to fix this and how to do this. So we could do potentially the right thing, which is take this software architecture that we're kind of deciding that we want, this accessor pattern, and apply it to the slot map as well. Because now that we're interfacing in that way with the slot map, it would be easier if the slot map could interface with this middle layer in the same way. That would just make for easy implementation, and potentially in the future, if we want to access the slot map directly in that way, it's now available to us. Or we could do the janky thing, which would be to run the iteration, run this lambda iteration once, store all of the information that we got from it, and then put that into the accessor and have like a really simple finish next and get function out of that. We would have to do all the iteration once, and then we do it again in the update loop. The second one would require more data, and we would make a copy of it, which means there's some potentially shady things that could happen if we modify some of the data in the behavior, in the actual asteroid's input behavior. If that data change isn't being actually replicated into the data that's stored in the accessor, that could cause some problems. So, well, I do love the jank, and I love getting things done as soon as possible, especially in a whiteboard setting. We're going to do the right thing here. And we're going to also implement this at the slot map level. It would be in, where's that, common? No. Is it actually just straight up in here? Yeah, oh yeah, it's straight up in here. Okay. So this is the slot map. This is the, if you're curious what I mean by slot map, there's, it's a CPP con, like stand-up talk, I think, that outlines how the slot map works. It's a very common concept throughout low-level memory management, but it's just codified in this word slot map. We have pages, we have indexes in these pages, and then when we delete a component, and this frees up, we take the last component, and in all the pages, we take the last component, put it there instead of trying to shift everything over, and then shrink the -1 to the count of the actual slot map. And so because we're doing this kind of memory management, we're kind of moving things around, we also have to have this idea of a handle, of a slight indirection when we do a memory, an actual element lookup, so that we're actually looking up at the correct position instead of the old position or the new position where we deleted something. So that's what a slot map is, very simply. Okay. So we wanted to take this loop through handles. It's a very simple function, luckily. And we're going to do structure. This is a handle accessor. Oh, we're getting deep here. A handle accessor. Get accessor. I don't really think, yeah, it doesn't look like there's any information here. We are going to want the same sort of interface, I believe. Let's see. I think this one's going to be very easy to iterate over though. Because let's see, let's break this down. We grab a walker while we're not walking. Yeah, so our pages are in a linked list together here, as you can obviously see. And we just call a simple get element in page, and this element gives us, oh, here's where we have to be careful. So this element gives us a pointer to, so each block in a slot map is header, element, footer. And this element doesn't give us access to the actual pointer to the element, which you would think. It gives us a pointer to the header. And so here we give, here we have to offset the actual element by the data header in order to get the actual element rather than the data header. So here's an interesting, another interesting thought. So when I originally wrote this function, I only passed this first argument you see here, or the pointer to the element. I then later extended it to pass the handle as well. And what this meant is that every function that calls this loop handle now has to change their lambdas parameters in order to match this. And this is something that Visual Studio does not communicate well. IntelliSense is not able to pick up on this because we're using this template indirection, this template argument indirection type thing here, where like the iterator doesn't know, or sorry, the lambda at the call site, the lambda doesn't know implicitly, well, not here because I just changed it, but the lambda doesn't know implicitly what its contract needs to be, what its function signature needs to be, because it's just being passed as a template. And the template is just assuming that whatever's being passed can fulfill this contract. And it's only at compile time where we learn that potentially there's an issue with the declaration of the lambda. And that can be problematic because, as we all know, template failures, compile failures are notoriously awful. So I think this one's just handle actually. So we're also getting rid of that issue by calling this accessor, because if we, for example, we were in the same situation where we're only passing this one, and then we suddenly decide, oh, I'd also like to have this handle information, we just add that to the struct. The struct automatically gets copied all over the place, and yes, we're taking that hit potentially, but we automatically update all the other places because we don't have to update any. Not that we automatically update, but we don't have to update any of the code in those places because it's not being passed through a function signature. It's just being passed as an object. Why am I using spaces? Please ignore the fact that, for whatever reason, Visual Studio is deciding to use spaces for my white space now instead of tabs, which it usually does. All right. So, in order to walk through this, we're going to need to keep track of our walker. We're going to need to keep track of this eye. So the way to do that would be simple. What is this? A slot, a page header, slot, main slot, page header, walker. We'll be more specific. Page walker. Then it's using tabs now. Oh, goodness gracious. U8 I. So this is finished if page walker is null, which can be seen here. We just need to invert this while, and we get our finished statement. The next is going to be slightly more complicated because we have to take into account both of these. So if walker element count, if I is greater than or equal to, do I need to invert this? Because this is going to keep looping until this is false. So what I want here is I want to know when this is true. So if I is greater than or equal to page walker, or no, this is what we'll do. Keep the exact same for loop, and then we'll do the for loop post action here, and then otherwise, which means we've escaped the for loop. We're doing this walker next situation, and I is equal to 0. Again, page walker. Page walker. Page walker. Okay, but what does this do on the first iteration? Yeah. I'll have to make sure to set, so when we create our handle accessor here, handle accessor, we eventually will return handle accessor. We'll want to say accessor dot page walker is equal to, what was that? It was page list, and accessor dot I is equal to 0. Something encapsulation. The outer functions that are going to be manipulating this shouldn't have access to this public API here, but unfortunately, in order to give this function access to that, these data members, like it's gonna have to be public. We could use the friend concept if we really wanted to care about encapsulation that much, but honestly, like, I'm kind of in the camp where just don't touch something unless you know what it is. There is, I will admit, that attitude has bug potential in it, right? But I would say that that's less than most habits. All right, so we're gonna roll with this. What is this get? This get is this. So we want to get the handle, or so we'll have a get handle and a get raw. Get raw. Get element in page. So I need access to the slot map. I'm going to say the same thing here. So slot map other map. Say map. Line page. Page walker. Okay. And here accessor dot map is equal to this. Very elegant. All right, and then so we can just return. Here we're going to return the handle. Yes, that's correct. Okay. Here we're going to want to return this, but like I said, plus as a data header. Don't forget to offset that header. Is there ever a situation where I actually want both? Why not? We'll have I don't want to do this. Direct access that here? Where is topple stored? Honestly, I don't want to use the tuple. Syntax. Where does the compare story? How expensive is get element in page? Ooh, not very much. Okay, so we'll just say we'll just say we're gonna live with that. All right. We've hit the unfortunate problem where I just wrote 3 functions and headers. Can you fix that for me? Let's see. See it, please. Move definition location. Perfect. This is not ideal. Alright. But gets the job done. There we go. And where'd all that end up? At the bottom? What? Gosh. Why are these all inlined? I mean, yeah, honestly, they really all should be, but still. We'll leave it, I guess. I'm not going to complain that much. Inline's just kind of a suggestion anyways. Okay. So, alright, so now we support this accessor API on the slot map level. We can go back to this. I'm actually going to do the same thing I did here because I kind of want to see the whole algorithm, the looping iteration, the looping approach that I took in this loop function, and keep that around while I'm implementing this, and then I'll move into the CPP file. So that's going to be my approach. Okay, yeah. So we set up. All right. So we set up the temp mask, and now we're going to want a handle accessor. Sorry, slot map, and full accessor. Accessor. All right. So instead of calling mask size handles entity mask map. Right. Okay. Yep. All right. I understand. Cool. We at this point need to create our set accessor. And in this accessor, we want to say, hey, the search mask is this search mask. All right. If people saw, this just got more complicated. And my argument for not using constructors right now just kind of got blown out of the water because of it. So we're going to move this search mask allocation and deletion into the constructor for the set accessor, because as you can see, the set accessor is going to keep a copy of it, and if we try to hit next after we've already turned and therefore deleted this set the search mask, that's going to be bad memory that we're trying to look at. So, all right, set accessor, and we're going to do the minimum amount that we can. Let's get into the map size. This is U32 mask size. And then we're going to pre-allocate the mask. We'll just do the same thing we did here. Take that out, put that in here. Get rid of auto. Get into the mask size. Very much easier now. I don't have to call this function. Mask size. And then set accessor delete search mask. And something copy constructor, something move constructor, not concerned with that right now. If it shows up on a profiler, I'll write a move constructor for it. Alright, you don't. Oh, well, actually. Yes. T. Size. Right, that, and then we just say it's give access to the same thing. What? Sure. What is this algorithm? Well, I'm still using it the same way down here as I'm using it up here. I've just moved the allocation memset outside of this. So I'm confident that that's still going to work. Just slightly strange. Let's actually take a look at this. So this temp mask, which is a reference, which is just a copy of the pointer in my search mask, we want to add okay. So take a copy, right? So this is the base. This is the base of the search of the mask. Move where this temporary pointer is looking at to the range in which the UID is in. So if you have multiple bytes in this search mask, you want to go forward, and then once you're in the correct range, go ahead and set that bit. Got it. All right, get entity mask size. So this is kind of the part that we completely replace with this accessor. So it may be accessor, that accessor. Really good naming schemes. We're gonna then accessor. We're gonna place that in accessor, and that's gonna be equal to the specific slot map that we're talking about, which is this entity mask map. Entity mask map dot get accessor. Alright. Join the accessor. Alright, so how do we know we're finished? The mix with handles is finished. Okay, let's go through this algorithm. So the map that we're going over is the slot map that contains the bit fields for each individual entity. The component owning bit field. So each entity has a bit field that represents which components they have, so that this this multi-component lookup gets simplified down into an OR operation on this mask. So, sorry, an AND operation on the mask, which is right here. This is the check. So basically, we loop through all the handles, and so we'll go through all the byte elements of the mask, and then individually on each byte of the mask, we're running the AND operation. And if any of them are false, then break. Otherwise, pass. So when we're saying finished, we're saying the same thing as mem access are finished, I believe. So what we want to do next is we're going to throw this in here, just to keep ourselves safe while we're going through, because we want to loop over every single one of the memory elements, but we don't want to stop at every single one. So we're going to keep going until we find one that's good. And once we find one that's good, we'll break out of this while loop. Or if we don't find one that's good, then the mem accessor.finish will be true, and then when we call finish on it again, it'll be true. This may cause problems. I can't remember the exact order in which for loops get worked on. So basically my concern right now is that we'll call next, and then next going to find out, oh, I'm done. Right, okay, so, all right. So thinking about how for loops work, this is still fine. What we're doing is fine. So next is going to end up figuring out that it's done, which is kind of exactly how an iterator or an I works, right? It figures out that, like, hey, or next isn't, well, next here is going to figure out that it's done, right? Explicitly, it's going to know that it's done. However, when we're talking about iterators, when we're talking about I variables, we're going to increment, and then it is implicitly going to know that it's done, because the next time that it runs its done check, it will be done. It will know that it's done in this middle set. The same thing is true here. We're going to run next. Next will explicitly, instead of implicitly like the integer does, the next will explicitly know that it's done, because it will end up calling finish as true, and that'll be okay, because this is called the middle one is called the beginning of the loop, like a while loop. This one's called the end of the loop. All right, so we're gonna find out if all that's true. I'm fairly certain, but like I could be wrong. Let's find out. Relying on the order of operations of implicit C++ structures always scares me, or any programming structure really. We'll find out explicitly. We'll probably do some breakpoints, figure out exactly what the order is. All right, mem access are finished. While finished, no, while not finished. Excuse me. While not finished, we're going to get auto mem get next. What is this? This is going to get, we want, which one do we want? Do we want raw or handle? I think we want raw here. Do we ever use this H? We return it. We're going to want both. We're going to want raw to do the calculation, and then we're going to want the handle in order to store it. So in all things where it's false, we actually don't want the handle. So we're saving some. We're saving some local memory space here. All right, get. This is auto. This is the int mask. The entity's mask. Switch mask. To mask. All right, and then we're going to do this same thing here. Yeah, I really should save that mask size. 332 mask size. Mask size. All right. So we have the mask size, and we go through this. All right. So we go through this. And if we ever find one that is false, then we want to call next and continue. If we ever get to the end, then we want to stop. Right? In fact, we want a full stop. So these are technically the same things, but it gives me a better idea. So I'm going to do this. So yeah, we've kind of inverted this logic here. So we get the raw on the mem accessor. And if we find a false one, we say, all right, go ahead, go to the next one and continue this. And if this ends up being finished already, then that'll be true. But if there's still more to look for, then we'll keep going. If, however, this never gets called, then we'll return, which leaves the mem accessor in a state where when we call get to the endy handle, we say return mem accessor get handle. Perfect. And then I just need to simply cast that. So entity handle, or not cast, but construct an entity handle using slot mem handle. Okay, I think that's everything in the set accessor. Which means you should compile now. Hit set accessor. Because I already know that's not going to be a thing. Just do that. Set accessor. Right. Oh, goodness. Okay. We don't have to worry about this. Alright, so that seems to be syntactically correct. Let's see if it's actually correct functionally. Should we just go for a raw run or stop through it? Let's stop through it because there were some things that we weren't quite sure how exactly they were going to work. And let's do that here. Finished. Alright. Oh, actually, I also want one here. I say it was syntactically correct. I haven't built this yet. I could be very wrong. I was. Dang it. Ooh, linker errors. Good. Unresolved symbol, finish void, and slot map will handle access or finished. Handle accessor. Oh, couple things here. Move you. I forgot to move these things. Move you. Handle accessor finish. That actually should very much be in the slot map CPP. I may have to do a manual rebuild because the build system on this project is exists. Handle accessor. Handle accessor. In slot map. I'm gonna say yeah that was just supposed to do this thing. Alright, move. I wonder if it'll move my breakpoints. Let's see how smart it is. It's definitely not going to move my breakpoints. Oh my god. Alright. Moved everything into component store.cpp. Some white space management here. Error here in this accessor. Now component store. Set accessor. Get set accessor. Oh boy. Not. Yeah, that's a little confusing. Oh well. Do manual build that, and then we'll do this. If that doesn't work, I'm going to go through. Yeah, inline shouldn't be changing this. I don't think it's inline, and yet I don't not think it's inline. Alright, so it can't find more functions than ever before now. Can't find the destructor, the constructor, next. Get. Get. Oh boy. Alright, yeah, we remove the inline because there is a suspicious overlap there. Alright, and then same in here. Alright. Try it, I guess. Why not? Succeeded. Okay. So that's a duly noted is don't use inline in CPP files because inline is only ever not going to happen. Actually, it helps a lot in H files. I could have marked all of this as inline in the H file. It probably would work. Ooh, oh boy. Oh no. That's right, I didn't remember my breakpoints. So it looks like there's some issue there. I mean, what we just saw, there was an issue with the destructor destroying the search mask that I provided it. So I guess we'll throw in here, here. I also wanted to check here, here, here. Just every single one of the new functions we wrote. Alright, so in the beginning, the mask size was 1. That's not correct. Max size should be at least 2. Yeah, entity mask. Oh no, it's 1 because there are 2 and that's less than 8. So it is 1. Perfect. Okay. And then we clear out. Yep, it's gonna. Of course, it's gonna view it like a character string. Should be 0. All right, accessor. And then we say, hey, mask. This should be 0 or 1, so that incremented at 0, didn't move it anywhere. This is 0, 8, 0, 1, shifted left 0 is 1, so we should mark this as 1. Okay, yeah, so the reason why we're seeing these y's here is because this is trying to be read as a null-terminated string, and obviously it's not a null-terminated string, it's a fixed-sized array. So it's reading past the actual memory bound, and we're really only concerned with this first character. Okay, so wasn't our first one 1? No, our first one was 0. This one is 1. Same deal. So this should now be, that should now be 3. We go to accessor, mask, yeah. Alright, so we have 3. And then we grab an accessor from you. We return the accessor. How could I forget? How could I forget? Oh, okay. I think what's the best way to do this? I really would love to use move semantics here. This is like the exact use case for move semantics. However, I don't strictly understand them well enough to do so. Why don't we learn though? Let's learn some move semantics right here. So I believe what we want to do is we want to write a move constructor, which is done like so. Set accessor, colon set accessor. And basically, we're gonna go with search mask RHS, and then RHS.search mask. And then we'll check to see. We're basically stealing the allocated memory here. Oops, sorry. Search mask. And then we'll copy everything else over like normal. Oh, so far fast. Alright, just the mem accessors equal to, sorry. Because we wrote this, we now have to write the rest of it. And then access. I don't know if we're going to end up using this. We're going to first off throw that into the correct location, remove inline, throw a breakpoint in it, so I want to make sure we're using it. Click here, and I'm pretty sure the last thing that we have to do is when we return it in, we're returning it get set accessor. Get set accessor. Get set accessor. There it is. We just want to slap this in the list. Alright. Let's try that one. Okay, so that's it. Boom, 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 boom. Set up the temp mask. Get that. Okay, yeah, and we call the move constructor. Perfect. Oh. If search. Important. Yep. So temp mask, move it, do a move constructor, then it's going to call this. This was set to null, so don't mind it. Are we finished? No, we're not. Oh, it's a for loop, not a while loop. Yep. Get handle. Alright. This looks to be, let's see, player 00, input garbage, but the player is the correct position and angle information. So I'm going to get rid of our breakpoints. We're going to run this and see what happens. Okay, so it's running. See that again. See if we actually. We're not getting our printouts here, which means we're stuck somewhere. Infinite looping. Yep. Yep. Sure. Yeah. Okay. Just take me to my last code. Get component. So we're infinite looping in here. Alright, so if finished. Take me to the. Alright, finished. Component store. Finished. This mem accessor. Again, please take me to the definition. Finished. Okay. Page walker. This. Should be hitting this next, shouldn't we? Alright. Do all the stuff. Alright, then we call set accessor next. Where's the next call? Oh, it's called right here. Perfect. Oh, no. No, I've confused some things here. I actually do think that. So this needs to return true if it wants to iterate, which is the same in a while function. Why did I think those are inverted? All right, so this is correct. If we're not finished, keep going. If I is less than something, then the max, that returns true, which means, okay, so this is true until it returns false, which is what we want. And same with this one. So let's see. Page walker is not false. Alright, so we're doing it here. And obviously, page walker is equal to null pointer is false, so this becomes true, so we iterate. Okay. So here's the problem. On a successful, right, fair enough. Alright, this is a hard problem. So basically what's happening is the next function is finding itself. So the next function needs to find the next valid state, but currently it's taking into consideration the elements already on. So sorry. The next function needs to find the next valid element. However, right now it is considering the element it is currently on, which is, as we know, is valid. So we need a way to say, hey, if we call next, manually move one over. And then here's an additional problem, is that we need the default state to be a valid. On creation, we want to find the first valid. And then every time we call next, we want to manually call next once. So if Is this a do while? Am I about to write a do while? If then accessor. This is how I want to write it right now. So if we're not finished, then go ahead and manually call next. And so this will get rid of the problem where the first, where we keep iterating over the same element. So it's going to manually move over one regardless or not if it's a valid one, which is correct. And then we're going to keep moving until we find a valid one. Cool. We have a problem right now, though. We're on its default state. This is what we'll do. We're going to do some fancy stuff here. No, we shouldn't. No, we shouldn't do fancy stuff here. I was going to pass a Boolean into next, whether to be exclusive or inclusive of that first element. Maybe that is the way to do it. It was going to be default, obviously, to true, or true being exclusive, and so it was going to skip this, or it was going to do this every time, and then on the constructor we call next exclusive, or inclusive. Okay, nah, let's do it that way. Bool exclusive, true. If we're being exclusive, which means exclusive meaning that we exclude the first element, inclusive meaning that we include the first element, and exclusive means not inclusive. And by default, we are exclusive. Component start.h, we need to put that default parameter in there. And the next bool exclusive is true, and actually, that we've done that. Technically don't need that there, but we do anyways. And then set accessor. We don't want to do it on the constructor because we haven't set up all the data by the constructor. It's here where we want to say accessor dot next false. And so that's going to do an inclusive next, which is going to take into consideration the first element. And then we're going. Okay, let's try this. No! Next reference. Result external symbol. Can't find it. Probably do it. H next exclusive is true. Spoonfee is the name of the custom engine, by the way. More than capable of finding it. Okay, it was just like confused. Alright, cool. So we're doing our exclusive next here. On this set get access, we call an inclusive next. Right, which means we do a lookup, we find that, hey, the first one's fine, return, move it, then we check, hey, are we finished? We're obviously not. Good. Go through it. And then we check finished. We're not yet. Right. Okay, so here we go. So we're doing an exclusive. So we do a manual next. Hit that I plus equals 1. Boom, boom. I'm going to start getting rid of these now. We're not finished. The next one's fine too. We're operating over a different entity this time, and we can tell that because that's still 0. And we're looping. Okay, and as you can see, these numbers are not ridiculous. In fact, potentially slightly higher than we saw before, so maybe this is faster. I don't have any profile from before, which sucks because I did some profiling. Why don't we do some more profiling, just to see if anything stands out to me. Please go ahead. Ugh. Sorry, the profiler or Visual Studio do that sometimes. If I really cared, or if I, not that I don't care, but if I really wanted to get diagnostics from the previous implementation, I would just git revert or go back on git commit and be able to get that profile information very easily in that way. Alright, 10 seconds of profiling on a no graphics loop. Okay, git component, cool. So yeah, we're still at this, we're still being limited by this unordered map lookup, which is again what I was looking for. This, I think this self went down. Let's see. Maybe it didn't, because these were the two big functions I remember reading before. This may have more gone up actually. But you also don't have to worry. Another benefit of using this approach over the lambda approach is like I don't have to look at anonymous lambda functions in my call stacks anymore, and my I can just simply breakpoint over things like a sane person, and I don't have to worry about jumping through all these anonymous functions in order to get this done. So that looks good. Okay, so yeah, thank you for talking through. What was that? About an hour of explanation plus implementation details and some pitfalls that we ran into that we pretty easily got over. There wasn't really anything incredibly difficult about this change, and I'm actually really happy with it for now. Let's make sure the game works again. Why not? I'll show off what it looks like to have 1,000 players. So I'm going to re-enable this, re-enable the player, or re-enable the renderer, and then re-enable the frame loader. And let's go. Well, that's really bad. Did I keep the 1,000 players? Let's knock it down to 1. Cool. Alright. So there we go. Still works. I may have to track down that 1,000 player issue. So I don't think that should be a thing, but I also haven't called Git Windows that much, so who knows. By the way, yeah, this is functional, at least partially, so nope, that bothers me a lot. I'm gonna go check it out. Why did it not work? Let's see if it works at 10. I still have half an hour to waste here. Hope you do too. Okay, it works at 10. Oh! Alright, I'm gonna say maybe it's a page thing? Because 10 of these components shouldn't need more than one page. Some pretty cool trailing effects there though, huh? It's strange that there are trailing effects though. I'm gonna I don't know if I did something. Why is my physics logic frame based? It really shouldn't be. Okay. Oh no. Well, it sometimes lives. I think if you're going down to the right, you get the looping, but if you go top to the left, you don't. Because of the way mod works. Really? Okay, so 100 of them work, but 1,000 doesn't. There may just be, I actually think in the 1,000 case, there may be some sort of memory limitation coming in somewhere. I do remember setting some max caps on some stuff that shouldn't be maxed cap technically. It's probably causing issues. Ooh, and off we go. It's just gone. Alright. I think that's what it is. I think it's some memory cap that I'm running into that I need to go throw assertions in for so that I can cleanly recover from that instead of what we just saw. So, alright. I'm going to call that a day for now. Yeah, doing a lot of line rates. Yep. So thank you for watching. This is kind of how I do my software engineering thought process, and a part of my implementation. The things and part of how I implement software. These are the kinds of things that I worry about. I think about when I'm writing software, and the constraints that I see in the APIs and the care that I put to make sure that in the future we won't be having issues with these things, especially when we're at a fundamental stage like this project is very early on in its life cycle. I want to make sure that not only are the things that we're doing the right things, but that we also have test cases like this asteroid game to make sure that the decisions we're making are sensible. Okay. Yeah, thank you very much for watching.